Okay, so good morning, everybody. Matthiusen will give his second talk here. Matthius? Yeah. We'll give his second talk here at Europython about Postgres for Pythonistas. Thank you very much.
Okay, that's better. So good morning. Good to see you all so here early and things. Who am I? What do I do? Why am I talking about Postgres? This is a very similar slide from yesterday if you see my other talk, but I'm a senior Python developer. I work for a company called Artrix. They are London-based, but I work from home in Glasgow. I'm primarily building sort of back-end systems and services, working with APIs. We've got like a large platform built around search and primarily around Elasticsearch. However, we then have other databases that we mix into it and use. We've got quite a good service architecture, so we can mix and match quite a lot. I've never really had a sort of a traditional database admin role. I more describe myself as a hacker which just likes playing with data and sort of databases and just seeing what you can do and what you can learn from them. And I'm a big fan of Postgres. So the agenda today is basically combining two of my favorite things. It's like, what can you do with Python and Postgres together to make the most of Python with Postgres and the most of Postgres with Python. And I'm going to be touching on these sort of four main topics. There was a talk yesterday by Craig Kirsten, who's actually sat up at the back. And we actually covered a lot of topics. I had a sort of a panic last night when I was looking at his slides and I was like, okay, I was going to talk about that. So rather than bore too many people, I kind of mixed things up a bit and I've tried to focus on a few areas. If you're missing a bit over the context and things, I recommend you go and check out his talk. He's a great speaker. So watch his talk if you didn't see it. Unfortunately, I missed it because I was speaking. These are the four things. I'm just going to start with a very brief history, just because I quite like where Postgres came from. So this is the brief history in sort of 3 words. It started at the University of Berkeley in California. It was a research project, and this was in, I think, 73. I didn't actually get the year for when it changed to when Postgres was started from Ingress, and that was, I think, sometime in the 80s. And basically, it was a similar sort of group of people sort of reinvented the project and started Postgres. And then in 1997, that's when it renamed to PostgreSQL, which is just kind of proving a point I'm about to make. And that was when they added SQL support to the language. And it's been kind of quoted by some of the core developers that this is one of their worst decisions was to use this name because it's just quite ambiguous. Nobody knows how to pronounce it. So everyone just calls it Postgres. As a sort of a side note, Microsoft's SQL Server was also adapted from Ingress. So there's some similar roots there. And they considered changing the name about 5 years ago, but they decided they wouldn't. So it's going to stay as PostgreSQL for now. The first one on my list, this is sort of the actual meat of the talk, is PL Python. So PL Python is a way for running Python within Postgres. It's about creating functions and stored procedures that you can access from SQL. And there are sort of a number of reasons why you'd want to do this. You can use all the Python libraries, so you can use anything on PyPI. You can reuse a lot of functionality. You can then speak to anything that Python can. So you can start accessing things over like a network resource. You can do anything you can imagine with Python, which is a lot of stuff. Writing Python is just nicer than working with PGSQL, which is sort of the Postgres-specific SQL for writing functions in SQL, which requires a lot more head banging than Python. Basically we all just like working in Python, right? So just to dive straight in, let's do like a really trivial function. How does it look when you're creating it in Postgres? And we'll just see how that works. So the first thing you've got to do is import the PLL Python extension. This is something you do once. You do this with create extension. It's kind of like an import or a load, and you can just think of it like that. And then at that point, you use the standard create or replace function in Postgres, but the one thing that's key is we're saying we're using the PL Python language. And here I'm creating a power function. So this is a completely trivial example to fit in a slide. It's something you wouldn't do because I'm sure there's a way of doing this in Postgres natively. So yeah, I'm defining Python_pal as the function name. It takes 2 integers and then it uses the Python built-in method of pal, so it's just a to the power of b. Using this is pretty much as you would expect from using any SQL function. So you can just do select Python pal 210 and 2 to the power of 10 is 1024. So that's a really simple example. One of the problems you find with working in this way is some of your normal workflow is broken. So you can't print, for example, because that's just kind of lost internally in Postgres because you don't get the standard out. You can use, there's this sort of PLL object which you have access to within your functions, and you can use that for logging. So this is the notice logging. There's all the sort of the standard ones you get in Python logging, like fatal and error and so on. They do have slightly different names, but they're all there and supported. So this is just basically adding a way for you to log, and you can also, of course, use the standard DB Python standard lib logging as well, so you can just log to a file. The one thing to note is if you do log a fatal error, it will abort the current transaction. It's kind of like raising an exception. And speaking of exceptions, the way that that works with Python PL is like this. So if you know the PAL function, then you'll know that PAL 0 to -1 doesn't make sense. That'll raise a zero division error. So I actually added in my own error checking, but it doesn't really do anything. It's sort of just to show you can just raise an exception normally. Yeah, and what this will do then is it's an error in Postgres, and if you're in a transaction, which you should be, it will be aborted. So say we now call it with that. Oh yeah, that worked. Yeah, so I'm now doing a call of the Python PAL function. So I'm doing 0 to the power of -1, which mathematically doesn't make sense. That's a zero division error. But then rather than just leaving it to the default zero division exception, I've raised my own just to show you can customize that a bit. Again, the problem with these kind of examples is it's quite hard to fit it all in on the slide. To make this more interesting, the next thing you can do is start to mix in this functionality with triggers. And I think this is when you can start to really implement something which adds sort of real benefit to your database. So basically a trigger in SQL, if you don't know, it's you have hooks in the database which you can then tell it to run these functions when those hooks happen. So for example, the one I've got here, I'm doing a hook which links into the update on events. So whenever there's an update on the events table, this trigger that I've created above will be called. And the trigger here is basically a Python function which I've called checkEditable. And what we're doing here is we're kind of implementing some logic constraints in the database which go a bit further than you could easily do with SQL. So what we have here is we've got a field called isEditable on the events table. And if that's set to false, it basically won't allow you to edit that row. It's going to raise an exception, and again, a current transaction will be aborted. The one thing to note here is you can see there's this sort of TD, which is just sort of globally available, essentially. This is to do with the triggers, and it allows you to access the row involved in the trigger. So you can access old and new. So because I'm doing an update, you've got what it was and what it will be after the update. So if somebody's setting it to isEditable false, then that will work because that's updating the new one. But because if it's already isEditable as false, then it won't work. And you can do all your sort of standard database accessing here. So you can do querying and you can do joins. So yeah, you might be looking up these flags on another table or something, and that works well. For that, you just use the. Oh, I've lost it. Oh yeah, so the PL_py.notice, it's got a whole bunch of other methods. So there's like pl.py execute, and then you can start querying the database from within your Python function and start getting more out. So yeah, showing you that in use, we have an update here, and we're going to assume that this row has got isEditable set to false. And what I'm trying to do is I'm trying to change the year of an event, which is something that might not make sense because perhaps the event's already in progress, so it's been set to false. I mean, we can't suddenly change Europython this year to next year. So yeah, and you can just see the exception I've done there is raised. And yeah, this is quite nice because it allows you to add quite advanced constraints into your database. It's something that you've got to be aware of using lightly. However, it's got some quite interesting use cases. So one that I find quite cool is you can use it with caches. So you can either warm up a cache or invalidate a cache. So say I've got a delete trigger, I could say when people are doing a delete, let's just remove that object from the cache, and that means it's invalidated, so people won't be getting the stale objects out of the cache. Or when I'm inserting or updating, I can then update the cache, and then it'll be warm and ready for when I'm hitting it. Quite often you would rely on updating your cache when you sort of first hit a view, if you're doing sort of web development, and that then adds a bit of extra work to that first request. So here we can do it in the background. The other good thing about PL Python is avoiding network trips. So if you're doing something quite query intensive, you can have a bit of a speed up by you're just not sending data over the wire. So you basically do your reporting internally and then send everything out at the end. And yeah, I mean you can go really quite far with this. So I like the sort of the event-driven style of it. So triggers are really quite cool. So you could then start triggering it for like message queues, or you could send emails perhaps. It allows you to sort of retrofit features into a database. And so say you're working with a legacy database, or you're working with something you can't change, like a third party. One of the uses I've seen in a place which was quite interesting is somebody had added a trigger on track. So when a new ticket was added by a certain person, they could then have an email sent to somewhere, and they're just sort of automating a few things like that. And that means you don't need to touch the track database. You're not affecting the database in any, sorry, you don't need to touch the code. You're not affecting the database in any ways, and you won't break anything, assuming your code is well tested and so on. Yeah, there are, however, some pretty grave limitations with it. You can't use it with a virtual env that I know of. If anyone knows about a way of doing that, I'd really like to know. And because it runs as the sort of the Postgres user, it's got super user privileges. So there's some sort of dragons here, basically. Debugging is a pain, and this is mostly because you're breaking outside of your normal Python workflow. You're working within sort of SQL and things, and you're not just doing your normal development style in your editor necessarily. However, the one way to get around that is to create your code as something which is then sort of pip installable into your site packages, and then you just have a simple wrapper in PL Python. So you're just doing like an import and a call of something, and it's just sort of an entrance point to the code, and then you can work in it as normal. If you do, however, put it straight into the database, then you need to consider migrations. So with databases, when you're making changes to the schema, you've got schema migrations for adding columns and so on. But there's also data migrations. And when your Python functions are in the database like this, you need to basically consider them as being a piece of data that needs to be migrated and updated. And that kind of seems pretty hairy in my head. Yeah, and the final one is user moderation. This can be pretty magical. It's kind of a trick you want to bear in mind, something you can take advantage of, but try not to abuse it, because it's a fairly non-obvious way of something to happen. So you can cause a lot of confusion. So document well. Okay, so next I'm going to move on to ListenNotify. This is a feature in Postgres which is kind of like a message queue, or like pub/sub in Redis, or there's quite a number of different similar implementations. And it basically allows for you to connect to Postgres and listen to a specific channel for messages coming to it. So most of this is boilerplate again, but I've highlighted this of the 3 interesting lines. This is with psychopg2, and we're just connecting to the database. We're starting the listen on the events notify channel, and then we are polling it essentially until we get a message on that channel. So we're just waiting for a message. And at the end, I pop it off, take that message, and then I'm just displaying the message we've got. And so what's quite, you can start to sort of mix these things together. So you can start doing notify calls from your PL Python, which then triggers something externally, and you've got this sort of quite integrated system. There are of course dangers of just making everything a bit too tied together, but it can be quite neat as well. So yeah, this is just 2 examples of how you would send a message to that queue. The first one is the queue that I defined. The second one is another queue. Just you wouldn't really want to mix the data types. You either want to send text or JSON or something else. Yeah, so the first one just adds a quick message which then I can print out, and the other one sends the same message but then with some metadata attached so I can do something more useful with it. Yeah, so the interesting here is, I find, is mixing it with triggers and then sort of integrating it with perhaps with something with PL Python as well. The next one, which is, I find pretty amazing what you can do with it, is foreign data wrappers in Python, Postgres. A foreign data wrapper allows you to access an external data source and treat it like a native table. So an external data source can be a wide range of things. It can be static files. It can be something like a web service like Twitter, CouchDB, Redis, anything essentially. You just need to write the foreign data wrapper extension for Postgres. And the one that's doing this quite interesting, I didn't realize this until quite recently, is the foreign data wrapper is actually part of the official SQL standard. And it is a way for standardizing management of external data. So it's quite often referred to as just as the name at the top there, or SQL med. I think the original sort of the start of the implementation was added in Postgres in 8.4, but then became really quite complete in 9.1, which sort of follows the typical Postgres development style of adding something quite early as a core feature, and then over time improving the API to that, making it easy to use, adding more functionality, and sort of really fleshing it out. There are a lot of backends out there, so that was just a few that I listed. I think I done a quick Google last night just to check, and I found about 20 really quickly. The quality varies as with open source products. I don't know how many of those are actively supported and so on, or still work. But the Twitter one, for example, isn't ideal because I don't think it supports OAuth. I tried it like a year ago, and now Twitter has stopped the basic auth API, I think, so that's probably going to be blocked. I think I looked in GitHub and there was an issue about adding OAuth, so they're maybe trying to figure out how to make that work with the foreign data wrapper. So yeah, I'm just going to pick one, which is Redis, and sort of show you how we would access that from Postgres. So the first line we've got again is kind of the import, similar to PL Python. We're just saying, okay, let's create this extension and import it. And then we have, the rest is just sort of set up and config. So we're saying we want to access the Redis server on 127.0.0.1 on that port, and we've got a password, we're providing that. And that's it. So once we've done this, we can start to create tables which are mapped to Redis. The one thing I just realized I forgot to add in is you actually need to install these. They're not included in Postgres. But the documentation will cover these quite well for all the individual projects. They're all subtly different. Yeah, so now I've got it set up. I've told it where my Redis is and so on. I'm just creating a foreign table, which, so you can see it's quite similar to the create table syntax in Postgres, but there's the important foreign keyword up there. And then you can pass in a few options. These are all very specific to the particular wrapper you're using. But in this one, I'm telling I want to use database 0. So if you don't know Redis, it's a database which has, the server by default has 0 to 15 database. They're all named by the number, which is a bit odd if you're not used to it, but you do get used to it. Yeah, so now I've created that relation to the database 0 in Redis, so the first one, and then I'm just doing a select from that, and I'm ordering by the key. So Redis is a key value store. In this instance, I've just got string values. So yeah, they just display out like that, and it's just like a normal SQL result. The whole sort of accessing an external data source is pretty well abstracted. Right, but you might have more interesting data in your Redis server. So this time I've connected to Redis 1. This is simply because I had different keys and different data types in the different databases for my when I was testing. And this time we're telling it we're going to be accessing the hash type in Redis. So if you don't know the hash, it's basically a mapping. It's a type in Redis which is of a key value mapping. And that maps very well to Agestore in Postgres. I think Craig covered Agestore at least briefly in his talk yesterday, but Agestore is a column type in Postgres, which is a key value mapping as well. So they map very well to each other because they're both one level deep, and they're both strings at both sides, so both string keys, string values. So with the foreign data wrapper, it understands this, and I can say, okay, when I'm selecting this, I can just want to convert this to an HStore. So it does all the conversion behind the scenes, and then I get the result. This is what an HStore looks like when you're selecting it on the command line. However, it's more like an object than a string that looks like that. And you can do all the different other like Postgres functions on an HStore. So you can access individual keys. You can then insert it into another database table which has got an HStore column. Yeah, so that's how you use a foreign data wrapper. They're all pretty similar in a way. You do a bit of setup, defining where you're going to be, like importing the particular wrapper, and defining how you're going to be accessing it, which host is it on, and so on. But how do we write one, right? So most of the foreign data wrappers are in C. So, I mean, does anyone here like writing C? I mean, a quick show of hands. Oh, we've got a few people, a bit more than I expected, but you know, it's not too surprising. So the problem with writing in C is you can end up with quite a verbose thing for something that could otherwise be quite simple. So these are quick line of code counts for 2 that I checked. Redis is about 1,500 lines, MongoDB is about 8,000. So it's not actually that big, but you know, for me it's not particularly fun. So thankfully there's a way around that. We can write our foreign data wrappers with Python. And the way this works is there is another foreign data wrapper called Multicorn, which basically gives you a bridge to writing foreign data wrappers in Python. So it's a C one which will then interface into running some Python code for you. And one thing that's quite interesting about it is it actually comes with a number built in. So it's an individual foreign data wrapper in a way, but then it comes with support for like another 7 or 8 internally. So it supports things in like the Python standard library like IMAP, CSV, and it does RSS, which I guess is with the XML module. Yeah, so you can do quite a lot with it. And oh yeah, one thing to know, if you do want to write them in C, the Postgres documentation covers it really well, but it's quite a big topic. And yeah, as always, the Postgres docs are really good. So if I was writing one in Python, what would it look like? So this is quite a dense slide. It's too big an example for a talk, really, but I just wanted to show that I could actually fit it in one slide. And it's pretty simple. So this is an iCal foreign data wrapper. So we're just querying a calendar with Postgres, essentially, is what we'll be able to do. And there's basically a little bit of setup, just with the sort of the URL and the options, and then we have an execute, which then goes and uses the calendar library and the iCal and URLib, and yeah, it just yields out line by line. So this is like each yield is basically returning, well, it's not returning, it's yielding a row in your SQL results. The API isn't too bad for writing these, it works quite well. Oh yeah, and there's a good guide in the Multicorn docs, so if you want to have a much more broken down way of how you'd write them, it goes into really quite a lot of detail. It's got a few examples, and then it steps right through them one by one. But yeah, so it's pretty good that you can write one in about 30 lines of code. And if you want to use just some of the ones that are built in, so this is the IMAP one, so this is quite neat. And I was playing with this actually. So this is how you can set up a Gmail foreign data wrapper with Multicorn. So you can then query your emails from Postgres. So this could be useful if you just want to do some, like, I don't know, you just want to find something in your email you want to hack around, or you want to do something longer term, like loading all your emails into a database to then build another system, or do some reporting around it. This is mostly just sort of boilerplate, and it's pretty much copied from the Multicorn docs. But yeah, it's a nice little example. And you can just see at the bottom there, we're just accessing it like a normal table. And yeah, I'm just looking for emails with the subject with Europython in them. But what if we want to do something more interesting, something a bit more sort of meta, something kind of, yeah, just a bit more crazy really, I guess. You could technically use so Multicorn also has support for SQL Alchemy. So you can use Multicorn with SQL Alchemy to then access another database that SQL Alchemy supports. So it's kind of, you're going these levels deep. And if you really wanted, you could actually access the database you're in. So it's like a foreign database wrapper to your current database. I mean, this is kind of getting to silly examples, but it's, yeah, I kind of like to think of it as foreign data wrapper inception, and it kind of blows my mind a little. So, But yeah, so, well, I mean, there were kind of funny examples and things, and I think they're pretty cool. But what is it useful for? So yeah, if you want to do sort of moving data around, one thing to know with foreign data wrappers, they are read-only at the moment. So it's more for if you want to do reports from Postgres, or you want to load something into Postgres, or that kind of thing. What's really neat, you can do joins. So you can do a join between your native Postgres tables and your foreign data wrapper tables, or you can do joins across different foreign data wrappers. So you could do an SQL join technically between Redis and MongoDB, and yeah, it gets a bit insane. But I mean, there are problems with this, so it starts to get really slow. The more you're mixing in, the SQL query planner doesn't have a huge amount of information to go on. It's loading a lot of it into memory, I think is how it works under the hood. So yeah, it can be pretty slow, so sort of use with caution. And I think it's generally good if you want to do sort of reporting and that kind of thing. It's a good way to bring a lot of data together. Okay, yeah, and because yesterday I rattled through my talk, I just added in a quick bonus slide. I've got a couple more. So this is async queries in Postgres. So this is something I've been starting to experiment with. I don't know it too well, to be honest, yet, but it allows you to do an asynchronous query in Postgres. So this is with psycopg2 again. So when you create the connection, you say it's async, and rather than just receiving the results straight away, you get you have to then wait for the result to come out. So it's a bit strange. It's like a sort of a deferred implementation. And what it allows you to do then is while you're waiting for the query to finish, you can do something in the meantime. So this is a sort of a trivial example to delay the query, but then while we're waiting, we can do something useful here, and then we start waiting for the actual result, and then we can just print that out. One of the sort of use cases I've been thinking about this is, say, in Django or like or Pyramid or anything, if you've got a web view, you could trigger off your asynchronous queries at the start of the view, because a lot of your data you might just be like basically sending through to the template. You can then do your other bits and pieces in your view that you need to do, and then wait at the end for the result to come out. Oh yeah, the one caveat with this example is the wait function isn't actually built into psycopg2, but the example is in the documentation. And the async is got to be connection wide, so it's like a global setting on the connection. So I was trying to figure out how to use it with Django, but I think the only way to really do it is to have two open connections, because otherwise, if you change the Django's connection to async, it just breaks because it's expecting results to come back and not a handle. And yeah, there's one thing I just wanted to quickly plug, which is stay up to date with what's going on. There's always a lot going on in the Postgres community. I'm not actually involved with it, as in I don't write it or anything, I'm just a reader. I'm pretty sure Craig does it. Yep, Craig does it in the back there. So yeah, props to him for that. It's really interesting. Yeah, and finally, just sort of move on to questions and yeah, comments.
Okay, one second. I would like to know, probably I missed it, or I don't know, but which version of Python does support the language?
Okay, so I'm pretty sure it's using the sort of the standard your system-wide Python version, so your default.
Oh, okay.
So he basically asked my first question. So the second question is, what's the overhead like of using PL Python in Postgres? Does it have a startup overhead? Does it have a per call overhead?
Okay, so when you create the function, behind the scenes, I almost put this in from the documentation, but I didn't. So it sort of generates the code, which has got like a special name, and then it calls that each time. So it's not like it's reinitializing the code each time it's used. It is sort of the bytecode is cached. So the startup time isn't too bad, but yeah, I mean, there's a typical Python overhead. How it compares to, say, the PG SQL, I'm not too sure. It's going to be one of those things, depends what you're doing, really. And if you're using lots of external libraries and things, then yeah, you could add a lot of overhead.
Can you also access Python C extensions?
Yes, I think so.
Yeah.
Yeah, I mean, it's literally just calling out to your native Python, as far as I'm aware.
Okay. Thank you.
No.
Thank you very much.
Yeah, thank you.